We're here on the Nexperia stand in Hall 9 with Chris Boyce. Chris, you've got some innovative solutions, I think, for the wide band gap offering that you have. Perhaps you could tell us a bit more.
Sure, yeah. Great to be here. Great to be back at a show again, which is brilliant. Yeah, what we're showing here is our latest offering in the gallium nitride space. We have already got a TO247 product that has been released and out and about for a while. What we're showing here is the new CC Pack 1212 package, which will be released later this year. The cool thing about this is that it's all based upon copper clips. So some of your viewers may be familiar with our LF Pack package in power MOSFET area. We were the kind of pioneers of copper clip. CC Pack copper clip package is taking that expertise and that experience and bringing it in an innovative way to the gallium nitride products that we offer. And you've got a few examples here. We've got an evaluation board that we've put together ourselves. We've got a Broadcom reference design showcasing one of their gate drivers, all based upon this CC Pack package.
And what's the main advantage for an engineer if they're considering wide band gap? What does CC Pack bring for them?
What CC Pack brings, number one, it's surface mount. Number two, it's because of if you think about what's happening inside the package, there's no long bonding wires inside the package. That reduces the inductance and allows you to drive at higher frequencies.
You've got a surfboard hanging from the ceiling there, and I'm guessing Nexperia aren't suddenly selling surfboards.
No, we're not selling surfboards, but this is an example of the explosion in e-mobility solutions. We used to have bikes, now we have e-bikes. We used to have skateboards, now there's e-skateboards. We used to have paddle boards, now we have e-paddle boards. So this is a thing known as an e-fin, and this contains a propeller, a motor, a battery, and all of the electronics to drive that. The reason that it's on our stand, of course, is that it's using our LF Pack MOSFETs in parallel to get the required power and the required efficiency so that the battery lasts long enough for it to be a usable product.
So motor control is obviously an important application for Nexperia. What do you bring to the table that maybe other people don't bring?
One of the most important things for motor control, and we hear it from every customer that's involved in this, is how do you handle a high current application? And that's because at some point there's a risk that the motor gets a locked rotor, whether that's seaweed in here or you're drilling into concrete and it jams. You can have overcurrent protection that protects everything, but then your drill's stuck in the concrete. You need it to jerk in your hand. And to make it jerk in that hand, you need to be able to support hundreds of amps through the motor. And that's what our products do.
That's the overload.
That's for the overload. It's in our terms, it's DC because it's maybe half a second repetitively. No one's going to drive hundreds of amps through a MOSFET continually, but you need it when you need it. When you've got that golf buggy that's up against the curb, you need to be able to get up there.
Thanks for the explanation, Chris.
My pleasure.
You've got lots of power products. Why would a design engineer choose Nexperia, and what support can you offer them?
Thank you very much. We work closely with our customers' design engineers. We obviously talk to lots of people inside our customers, but there's only one group of people who can definitively say, yes, I'm going to use Nexperia. We have to get qualified, we have to get on that design, and that's the design engineer who can do that. So we've got some great products, but it's not just about the products. In terms of helping the engineers use those products, it's all about the support tools. We have this fantastic book here. This is our application handbook. We're on our third edition now. We've shipped tens of thousands of these things. We've just done a survey amongst the recipients, and it's seen as the MOSFET Bible, the real referenced work that you can't do without. So that's just one example of the sorts of things that we provide. Our latest precision electrothermal models are the most accurate simulation models that we've ever produced. They work and take account of the fact that as you use a MOSFET, it heats up. And a lot of parameters change with temperature. The latest models reflect that, and you end up with a much more accurate simulation. It's just part of the advanced support tools that we offer.
So if a customer or a design engineer wants to get their hands on that book, where would they go?
Well, if they happen to be at Nuremberg, they can pop in here and we can take their details and send them one. or they can apply online. You have a choice of either downloadable PDF, or if you like to have the book that you can read in the bath, we can send them a hard copy as well.